Hello, in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle, A or B is a quarter circle. We know that side OB equals to 2 units in its length. And we also know that line segment AD equals to line segment DO. And this angle DCB equals to 90 degrees in its size. Our mission is to find out the area of this green shape. The green shape is actually the right triangle DCB, or in other words, our mission is to find out the area of the right green triangle, triangle DCB. Okay, first of all, we know that AOB is a quarter circle, therefore angle AOB, this angle equals to 90 degrees in its size. In addition, because of the fact that AOB is a quarter circle, it means that sides AO and OB, they are both the radii of this quarter circle, but we know that OB equals to 2, therefore it means that the radius of this quarter circle equals to 2 units. Therefore, the radius AO must be also equal to 2 units in its length. AO equals to 2. And we also know that AD equals to DO. So if we define the length of line segment AD as x, then the length of DO must be also equal to x because they are equal to each other. AD plus DO equals to AO. Again, AD plus DO equals to AO. AD is x, DO is x, therefore AD plus DO is x plus x, and x plus x equals to AO, but AO is 2, therefore x plus x equals to 2. X plus x equals to 2, x plus x is 2x, so 2x equals to 2, we divide this equation by 2, we get that x equals to 2 over 2, that is 1, so AD that is equal to x equals to 1 unit, and DO that is also equals to x, it is equals to 1 unit. In the next step, we will complete this quarter circle to a circle. Actually completed this quarter circle to a circle, and we'll extend the radius BO by straight line until it touches the circle. BO as a radius, it is absolutely a straight line, and when we extend the straight line BO by straight line, the result must be a straight line. We define the touching point of the extended radius BO with this circle, this point is point P. Repeat again, we extended the straight line BO by straight line, therefore the result BP must be also a straight line. So we know that BP is a straight line. If we focus on the upper side of this straight line BP at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BP at point O? We have this angle that is a right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So I found out that BP is a straight line, but BP is a straight line that touches the circle at 2 points, B and P. Any straight line that touches the circle at 2 points, it is defined as a chord. So we know that BP is a chord, but BP is a chord that passes through point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, BOP is the diameter of the circle, and if BOP is the diameter of the circle, it means that BP is the diameter of the circle. So in conclusion, we can find out that BP is the diameter of the circle. And what is the definition of line segment PO? Line segment PO starts from point O, that is the center of the circle, and ends at point P, that is a point on the circle itself. So this is exactly the definition of a radius. Therefore, PO is the radius of this circle, that is equal to 2 units. In the next step, we'll extend side CD by straight line until it touches the circle. Okay, but the question is where side CD will touch the circle. We will assume that the extended side CD will touch the circle not at point P but at another point. We assume that the extended side CD will touch the circle at this point that we will define as at point G. So by extending side CD by straight line until it touches the circle at point G, we created here peripheral angle BCG. This peripheral angle BCG equals to 90 degrees in size because this angle equals to 90 degrees according to what is given as the question. So we actually have here peripheral angle that is equal to 90 degrees in its size, and it is subtended on BG, on chord BG. Okay, but this is a contradiction to Rule 5. I'll take quickly on Rule 5. According to Rule 5, any peripheral angle that is equal to 90 degrees must be subtended on the diameter of the circle. Here we have peripheral angle MAN, and it is equal to 90 degrees in its size, and as you can see on drawing that this peripheral angle MAN is subtended on MN, that is the diameter of the circle. But according to our assumption, peripheral angle BCG that is equal to 90 degrees in its size, it is subtended on chord BG. But the problem is that chord BG is not the diameter of the circle. Why? Because from point B we have only one diameter to this circle, that is the diameter BP. Any other point in this circle will not be the diameter of the circle. So BG is not the diameter of the circle, and we have peripheral angle BCG that is equal to 90 degrees in its size, and it doesn't subtend on the diameter of the circle. It is contradiction to Rule 5, because any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle. So our assumption that the extended side CD will touch the circle at point G will give us a contradiction, because we will have peripheral angle that is equal to 90 degrees in its size. Peripheral angle BCG is equal to 90 degrees in its size, and it doesn't subtend on the diameter of the circle, that is BP, and therefore it is contradiction to rule 5. Because any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle. In order to avoid contradiction to rule 5, we must conclude that the extended side CD will touch the circle at point P. Okay? The extended side CD will touch the circle at point P. Now we have here peripheral angle BCP that is equal to 90 degrees in size according to what is given us in the question, and indeed this peripheral angle BCP that is equal to 90 degrees, it is subtended on PB, that is the diameter of the circle. We don't have any contradiction to rule 5. Okay. In the next step, I'll copy the right white triangle DPO in a new page, and we will implement the Pythagoras theorem on this right white triangle DPO in order to find out the length of the hypotenuse DP. Okay. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Actually, this is the right triangle DPO, and according to the Pythagoras theorem, in this right triangle DPO, dP square equals to dO square plus dP square. Again, dP square equals to dO square plus OP square. dP square equals to dO square plus OP square. So write it down. dP square, that is the square of the hypotenuse, equals to dO square plus PO square. The hypotenuse dP is the missing side, so we leave it as it is. You get the dP square equals to dO square. dO is 1, therefore dO square is 1 square, that is 1, plus PO square. PO is 2, therefore PO square is 2 square, that is 4. So in total, found out that dP square equals to 1 plus 4, that is 5. dP square equals to 5. We take out all of this equation, and you get that dP equals to the square root of 5 units. Okay, dP equals to the square root of 5 units in its length. This is side dP, it is equals to the square root of 5 units in its length. In the next step, we define the size of this angle DPO. This angle is theta, and we focus on the right triangle DOP. The right triangle DOP, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. y equals 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we'll focus on the right big triangle PCB. In the right triangle PCB, this angle equals to theta. This angle equals to 90 degrees, therefore the missing third angle must be equal to 90 degrees minus theta. In the next step, we'll prove that the right big triangle PCB is similar to the right small white triangle PDO. So write it down. The right big triangle PCB is similar to the right small white triangle PDO. So why the big triangle PCB is similar to the small white triangle PDO? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So okay, this is angle DOP. In the white triangle PDO, and it is equal to this angle. This is actually angle PCB in the big right triangle PCB. Repeat again. Angle DOP in the small right triangle PDO equals to angle PCB in the right big triangle PCB. They are both equal to 90 degrees, therefore they are equal to each other. In addition, we have this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle theta as it belongs to the small white triangle DPO, it will be angle DPO. And if we relate to this angle as it belongs to the right big triangle PCB, it will be angle BPC. Repeat again. Angle DPO in the right white triangle PDO equals to angle BPC in the right big triangle PCB. It is actually angle theta that we call to angle theta two different names. So angle theta actually equals to itself as a common angle that belongs to both triangles. So repeat again that this equation means that angle theta equals to itself, we just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, this is angle PDO. The right triangle PDO, and it is equals to this angle, that is actually angle PBC. In the right big triangle PCB. Repeat again. I found out that angle PDO in the right small triangle PDO equals to angle PBC. In the right big triangle PCB, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually found out that all the figures of the right big triangle PCB are correspondingly equal to all the figures of the right triangle DOP. Therefore, the right triangle PCB is similar to the right small triangle PDO according to angle similarity rule. So write it down. So we found out that the right big triangle PCB is similar. This is the sign of similar to the right triangle PDO according to angle similarity rule. And from the fact that the big right triangle PCB is similar to the right small triangle PDO, we derive that the following relationship exists between their sides. We derive that side DP in the right small triangle DPO over side PB in the right big triangle PCB, and again side DP in the small triangle over side PB in the big triangle is equals to side DO in the small triangle DPO over side CB in the big triangle PCB. Again, it is equals to side DO in the small triangle over side CB in the big triangle, and it is also equals to side PO in the small triangle PDO over side PC in the big triangle PBC. So actually found out that dP over PB equals to DO over CB equals to PO over PC. DO equals to square root of 5 units over PB. PB is the diameter of the circle, and it is equals to 2 plus 2, that is 4. The diameter PB equals to 4, and it is equals to DO. DO is 1 over CB. CB is the missing side, so we leave it as it is. And it is also equals to PO. PO equals to 2 over PC. PC in total equals to DC plus square root of 5. Repeat again. PC in total equals to CD plus square root of 5. So we found out that according to equation 1, square root of 5 over 4 equals to 1 over CB equals to 2 over CD plus square root of 5. Those two expressions are equal to each other. Therefore, create equation 1 from those two expressions that are equal to each other. So according to equation 1, square root of 5 over 4 equals to 1 over CB. Here we cross multiply this equation, equation 1, and we get that according to equation 1, square root of 5 CB equals to 4. Here we divide this equation, equation 1, by square root of 5, and finally we get that according to equation 1, the length of side CB is equals to 4 over square root of 5. So if I found out that the length of this side CB is 4 over square root of 5 units. We continue to focus on the log equation, question 1. According to equation 1, the third expression square root of 5 over 4 equals to the first equation, the first expression square root of 5 over 4 equals to 2 over CD plus square root of 5. So those two expressions are equal to each other. So we get equation 2 from those two equations that are equal to each other, from those two expressions that are equal to each other. So then, according to equation 2, we shall find out that square root of 5 over 4 is equals to 2 over CD plus square root of 5. Here we cross multiply this equation, equation 2. And you get that according to this equation, equation 2, square root of 5 times CD over square root of 5 equals to 4 times 2, that is 8. Here we open the brackets on this side of this equation, equation 2, and get that according to this equation, equation 2, square root of 5 times CD is equals plus square root of 5 times CD, and we have square root of 5 times square root of 5 is 5, so it is plus square root of 5. Square root of 5 times square root of 5 is 5, so it is 5 equals to 8. Here we subtract 5 from this equation, equation 2, and get that according to this equation, equation 2, the square root of 5 times CD equals to 8 minus 5 is 3. So here we divide this equation, equation 2 by square root of 5, and finally we get that according to this equation, equation 2, CD equals to 3 over square root of 5 units in its length. Okay, I should found out that this line 7 CD is equals to 3 over square root of 5 units in its length. Our mission is to find out the area of this green shape. The area of the green shape, it is equals to the area of the green right triangle DCB. So the area of the green shape equals to the area of triangle DCB, and note that the area of any triangle equals to the base of the triangle times the height to the base over 2. Now, triangle DCB equals to the base of the triangle times the height to the base over 2. So the area of the green right triangle, this is the area of the green shape, equals to the base, we choose the base as DC, times the height. The height is CB, well, because the height, CB creates 90 degrees with the base, DC. So the height is CB over 2. Okay, again, if we found out the base is DC, the height is CB divided by 2. We have already found out that DC equals to 3 over square root of 5 times CB is equals to 4 over square root of 5 divided by 2. So the area of the green shape equals to 3 over square root of 5 times 4 over square root of 5 over 2. Here we have 3 times 4 is 12. And in the denominator we have square root of 5 over square root of 5 is 5 over 2. So the area of the green shape equals to 12 over 2, 12 over 5 over 2. 12 over 5 over 2 is 12 over 5 times 2. So the area of the green shape is equals to 12. In the denominator we have 5 times 2, that is 10. There the green equals to 12 over 10. We divide both the numerator and the denominator of this number by 2. 12 over 2 is 6, and 10 over 2 is 5. So if I found out that there the green shape equals to either 6/5 square units, or terms of numbers, there the green shape is equals to 1.2 square units. Repeat again, if I found out that the area of this green shape equals to either 6/5 square units, or in terms of numbers, it is equals to 1.2 square units. So in the next step, I'll summarize the lecture. In this lecture, I found out the area of this green shape. So in the drawing we have a quarter circle, AOB is a quarter circle. In addition, we know that side OB equals to 2 units in itself, line segment AD equals to line segment DO, and this is angle DCB that is equals to 90 degrees in its size. I repeat again, our mission is to find out the area of this green shape, but the green shape it is actually the right green triangle DCB. So our mission is actually to find out the area of the green right triangle DCB. So first of all, we know that AOB is a quarter circle, therefore this angle AOB must be equal to 90 degrees in its size. In addition, because AOB is a quarter circle, it means that sides AO and OB, they are both the area of the quarter circle, but it is given us the equation that OB equals to 2. Therefore, the radius OB equals to 2, and therefore AO, that is also the radius of this quarter circle, must be also equal to 2. AO equals to 2, and we also know that AD equals to DO. So if we define AD as x, then DO must be also equal to x because they are equal to each other. So AD is x plus DO is also x. AD plus DO is x plus x, that is AO. AD plus DO is AO, therefore AD is x, DO is x, so therefore AD plus DO is x plus x, that is AO. But AO equals to 2, therefore x plus x equals to 2, x plus x is 2x, so 2x equals to 2, we divided this equation by 2, if I found out that x equals to 1. So x that is equals to AD according to our definition, it is equals to 1, and DO that is also equals to x according to our definition, it is equals to 1. Okay, so in the next step, we did the construction. Actually, we completed this quarter circle to a circle, and we extended the radius BO by a straight line until it touches the circle. We define the touching point of the extended radius BO with this circle, this point as point P. So BO is a radius, it is absolutely a straight line. When we extended the straight line BO by a straight line, the result is a straight line, because when we extend the straight line by a straight line, the result must be a straight line. Therefore, PP must be also a straight line. Then we focused on the upper side of the straight line BP and point O. In the upper side of BP, point O, the sum of the angles must be equal to 180 degrees according to rule 3, that the sum of the angles to one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BP at point O? We have this angle that is the right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Okay. So we know we have found out, we just right now found out that BP is a straight line, but BP is a straight line that touches the circle at point B and point P, 2 points. Any straight line that touches the circle at 2 points is defined as a chord. Therefore, BP is a chord, but BP is a chord that passes through point O, that is the center of the circle, And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, BP is the diameter of the circle. Okay, here BP is the diameter of the circle. In the next step, we did a construction. That is to say, we extended side CD by a straight line until it touches the circle. The question is, where the extended side CD will touch the circle. We will assume that the extended side CD will not touch the circle at point P, but it will touch the circle at point G. Okay? According to our assumption, the extended side CD will touch the circle at point G. And by creating this peripheral angle BCG, by doing this construction, we created peripheral angle BCG that is equals to 90 degrees in its size. And according to rule 5, any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle. But we have a peripheral angle BCG that is equal to 90 degrees in its size, and it doesn't subtend on the diameter of the circle, because BG is definitely not the diameter of the circle. Why? Because from point B, we have only one diameter to this circle. And the only one diameter that we have here, the diameter BP. And therefore, BG is definitely not the diameter of the circle. Therefore, we have a contradiction to rule 5, because we have peripheral angle BCG that is equal to 90 degrees in its size, and it still doesn't subtend on the diameter of the circle. In order to avoid the contradiction, we conclude that in order to avoid the contradiction to rule 5, we conclude that the extended side CD will touch the circle at point P and only at point P. In this way, we will avoid contradiction to rule 5. Why? Because then we will have peripheral angle BCP that is equals to 90 degrees in its size according to what is given us the question. And this peripheral angle BCP is indeed subtend on BP, that is the diameter of the circle. Okay, I repeat again that in order to avoid contradiction to rule 5, we must conclude that the extended side CD will touch the circle at point P and not in any other point. Okay. What is the definition of line segment OP? The definition of line segment OP, actually, line segment OP starts from point O, that is the center of the circle, and then at point P, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore, OP is the radius of the circle that is equal to 2 units, according to what we already found out. In the next step, I copied the right triangle DOP in a new page and implemented the Pythagoras theorem on this right triangle DOP in order to find out the length of the hypotenuse DP. This is the right triangle DPO that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle DPO is DP, therefore the square of the hypotenuse is DP square, and DP square must be equal to DO square plus PO square. Okay, DP is the missing side, so leave it as it is, so DP square equals to DO square. DO is 1, therefore DO square is 1 square, that is 1, plus PO square. PO is 2, therefore PO square is 2 square, that is 4. So in total, we found out that DP square equals to 1 plus 4, that is 5. DP square equals to 5, we took out of this equation and found out that DP equals to the square root of 5 units in its length. This is side DP, and it is equals to the square root of 5 units in its length. In the next step, we focused on this right triangle DPO. This right triangle DPO, we defined angle DPO, this angle is theta. So we continue to focus on this right triangle DPO. This right triangle DPO, this angle equals to theta, this angle equals to 90 degrees, therefore the missing third angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, in 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. Likewise, if we focus on the right big triangle PCB, the right big triangle PCB, this angle equals to theta, this angle equals to 90 degrees, therefore the missing third angle must be equal to 90 degrees minus theta. In the next step, we proved that the right big triangle PCB is similar to the right small triangle PDO. So why the right big triangle PCB is similar to the right triangle PDO? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we can prove that all the three angles in the right triangle PCB are correspondingly equal to all the three angles in the right triangle PDO, therefore the right big triangle, the right big triangle PCB is similar to the right triangle PDO according to angle similarity rule. Repeat again. We should found out that the right big triangle PCB is similar, this is the sign of similar, to the right small triangle PDO according to angle similarity rule. And from the fact that the big triangle PCB is similar to the small triangle PDO, we derive that the following relationship exists between their sides. That side DP in the small triangle over side PB in the big triangle equals to side DO in the small triangle over side CB in the big triangle, and it is also equals to side PO in the small triangle over side PC in the big triangle. Repeat again. We should find out that dP over PB equals to DO over CB equals to PO over PC. dP equals to the square root of 5 units over PB. PB equals to 2 plus 2, that is 4. It is the diameter of the circle, that is equals to 4 units in its length. And it is equals to DO. DO equals to 1 over CB. CB is the missing side, so we leave it as it is. And it is equals to PO. PO equals to 2 over PC. PC in total is equals to DC plus square root of 5. Or CD plus square root of 5. The conclusion can found out that according to equation 1, square root of 5 over 4 equals to 1 over CB equals to 2 over CD plus square root of 5. Those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. So according to equation 1, I can found out that square root of 5 over 4 equals to 1 over CB. Here of course multiply this equation 1, if I found out that according to this equation 1, square root of 5 times CB equals to 4. Here we divided this equation 1 by square root of 5 and finally found out that CB equals to 4 over square root of 5 units in its length. So this is side CB and this is side CB, and it is equals to 4 over square root of 5 units in its length. We continue to focus on this long equation 1. The first expression equals to the third expression, so we create equation 2 from those two expressions that are equal to each other. So according to equation 2, square root of 5 over 4 equals to 2 over CD plus 5. Repeat again, according to equation 2, square root of 5 over 4 equals to 2 over CD plus 5. Here of course multiply this equation 2, found out that according to this equation 2, square root of 5 times CD plus square root of 5 equals to 4 times 2, that is 8. Here we open the brackets on this side of this equation 2, and found out that according to this equation 2, square root of 5 times CD equals to square root of 5 times square root of 5 is 5 of course. So square root of 5 times CD plus 5 equals to 8. Here subtract 5 from this equation, equation 2, and finally found out that square root of 5 times CD equals to 8 minus 5 is 3. So square root of 5 over square root of 5 times CD equals to 3. Here we divided this equation 2 by square root of 3, and finally found out that according to this equation 3, CD equals to 3 over square root of 5 units in its name. So this side CD is equals to 3 over square root of 5 units in its name. Our mission is to find out the area of this green shape, but this green shape is actually triangle, the right green triangle DCB. So our mission is to find out the area of the green right triangle DCB. The area of any triangle equals to the base of the triangle times the height of the base over 2. Okay, again, the green shape is actually a triangle, and the area of any triangle equals to the base times the base of the triangle times the height of the base over 2. Choose the base of the green right triangle DCB as DC, and the height is CB. Why the height is CB? Because it creates 90 degrees with CD. This angle equals to 90 degrees. Again, the base is DC, the height is CB divided by 2. DC equals to 3 over square root of 5 times CB. CB equals to 4 over square root of 5 divided by 2. So here we have 4 over square root of 5 times 3 over square root of 5 times 4 over square root of 5 over 2 is the area of the green shape. 3 times 4 is 12, square root of 5 times square root of 5 is 5 divided by 2. So the area of the green shape equals to 12 over 5 over 2. 12 over 5 over 2 is 12 over 5 times 2. So it is 12, and in the denominator we have 5 times 2, that is 10. So in total the area of the green shape equals to 12 over 10 square units. We divided both the numerator and the denominator of this number by 2, and we found out actually that 12 over 2 is 6, and 10 over 2 is 5. So in conclusion, we actually found out that the area of this green shape equals to either 6/5 square units, or in terms of numbers, the area of this green shape equals to 1.2 square units. Okay, thank you very much.